I'm Andreas, Head of R&D at MARK Metallwarenfabrik in Austria. MARK is one of the main suppliers for small, deep-drawn metal parts in Europe and an important partner for automotive industries worldwide. In 𝗿𝗏 project, we want to demonstrate that sheet metal from scrap is directly usable for new parts. 2.3 billion deep-drawn parts a year, with speeds up to 600 strokes per minute and 0 defect as a target. MARK's sheet metal forming needs very good understanding of the processes and stable input parameters to ensure the high quality levels which automotive industry needs when they use our parts. One important input for our forming processes is rolled sheet metal. Usually this raw material is delivered in coils, and the strip is transported into the feeding presses with feeding units, where the flat material is brought into three-dimensional shapes. Within one batch, these coils have a very low variation in thickness and mechanical properties, and, if at all, these fluctuations happen slowly in a continuous manner. So the changes induced by changing material properties can be tracked by means of statistic process control, which indicates when we reach the limits of our production windows. This gives plenty of time to react to changing material properties by fine-tuning the tools and readjusting the measures in the middle of the allowed range. Changing the philosophy to using recycling material also completely changes the way we have to run and to control our processes. Instead of continuous strip from coils, we need to feed single blanks to the deep drawing press. We do this with help of a robot feeding system which takes the blanks from a magazine to the first forming station. This is the easy part of the needed change. It starts to get tricky when it comes to properties of the single blanks. Coming from different scrap pieces, the spread in properties within one batch of reforming material is much bigger than within a single coil. And the most significant difference to standard processes, these properties don't change slowly. They change from piece to piece. So the concept of statistical process control with interactions only when the processes slowly reach the allowed borders does not work anymore. This topic has to be addressed by the main goal for MARK within 𝗿𝗏 project: to get as much information as necessary out of the processes to be able to react instantly, and all of this in real time. To measure is to know. If you cannot measure it, you cannot improve it. This famous quote of Lord Kelvin describes in a few words what we are aiming for: finding reasonable ways to measure the most relevant parameters in our forming stations. This shall allow us to detect anomalies in the processes and subsequently change and control the processes by actuators. So currently we are equipping our tool with a lot of sensors for measuring forces, temperatures, accelerations, vibration frequencies, body sound, a lot of things like that. And we collect this data during our forming processes. As this generates an enormous amount of data, we have to develop data processing tools to pick out the relevant signals, which characterize the processes and show when deviations happen. In the end, we want to be able to tell if a part is okay or not by only viewing the process data of its production, not by measuring the part itself. Being able to indirectly judge every single part we produce will allow us to use mixed recycling material with its high variability in properties. Forming scrap to new parts directly without the standard route of melting and re-rolling new sheet metal, saves a lot of energy and costs and helps to protect our environment. It's a tough goal and a long way to go, but if you can imagine, you can reach it. Together, we mark the future. So take part and stay tuned with the Compass project.